This is a 200 km/h rocket that I built from spare parts from a leftover project that went, let's just say, south. After crashing this rocket, I looked at the airframe and said, how can I improve it? I still had a spare motor, so I decided to optimize the airframe to fly as fast and as high as I could. The rocket would be powered by an F-35 model rocket motor, and it would also have a data logger to record altitude and temperature. I was going to call it Seeker. For the top of this rocket I would be using a 75mm body tube, and for the bottom I'd be using a 56mm cardboard body tube, which I cut to the correct sizes, and then I had these two properly sized tubes ready for my airframe. I then made this cardboard bulkhead which would separate a data logger from the rest of the rocket. Then I got this Kevlar shock cord and attached it to the bulkhead. Afterwards I got my F-35 model rocket motor and attached an engine block to it. The reason you need an engine block is to stop the motor from rising up into the top of the rocket when it accelerates. If it does this and, well, shoots into all your avionics, you do not go to space today, my friend. Then I made this inner tube for the motor out of cardboard, which is really strong and doesn't catch fire. Once that was done, I glued that into the rocket with some centering rings and I put my motor inside. But then I realized this rocket reached an altitude of 1,600 meters with this motor, which is illegal unless I have dual deploy. Because you see, my rocket has a simple pyrotechnic delay, which detonates a charge which sets off the main parachute. It's all really simple and it works. However, a dual deploy rocket has two charges, one which deploys a drogue chute and another which deploys a main chute. The smaller drogue chute deploys first and allows the rocket to fall from a high altitude in a fast but controlled manner. Then at a much lower altitude the main parachute deploys, and this stops the rocket from drifting too far away. The thing is that if you want redundancy you need two more reserve charges, which in the end quadruples the amount of explosives in your rocket, which gets very illegal very quickly. It's almost as if the CAA thinks I'm trying to shoot down civilian airliners with this rocket. Anyway, I had no choice but to resort to using a less powerful D12 motor, which means the rocket would only fly to 170 meters. After that small setback, I made this attachment point for the Kevlar shock cord, which I tied on using the most sophisticated of knots. And after using an ungodly amount of hot glue, the two parts of the rocket were connected. Then I once again used hot glue to attach a really rudimentary parachute that has seen better days to my shock cord. Then I once again used hot glue to attach some launch lugs to the side of the rocket. Then I prepared a simple homemade board for the electronics of the data logger, of which I actually had two designs and I picked the one which was most compact. Then the electronics for the data logger were made, which stored all the data from altitude and temperature onto an SD card. And then I attached them to the panel using, you guessed it, hot glue. And that ended up fitting nicely in the avionics bay. Then I made some fins and filleted them. And then I made a hole for an onboard camera. But I didn't actually know what color my rocket would be. But then I remembered I could have just copied my thumbnail. So I went with red and white. Now that there was a decent paint job, we could head out to the launch site and launch this rocket.
Three, two, one, launch.
Yep, it was absolutely demolished. Looking at the spent motor, I noticed that the engine block was just completely missing. Also, the motor was no longer in its designated motor tube. Remember what I was saying about the engine block? I could also see some scorch marks in the wall, which also made their way to the outside, ruining the paint job, meaning the motor just ejected sideways. Looking at my transition/staging ring, I could see that it cracked in the wrong place, which is not good. I could also see that the bulkhead which separated the data logger from the dangerous parts was completely blown out. The 3D printed nose cone at the top of the rocket actually got punctured at the top when it smashed into the ground at 100 miles an hour. And the SD card adapter was facing upwards, which meant that the card actually fell out of this hole in the top of the nose cone, which means all the valuable data was lost. But worst of all, the same tube that I used for this rocket and the rocket before both got this weird buckling effect afterwards, and this was bad because I was going to use the same brand of tube for a future rocket, but now I'm having second thoughts. Overall, there were various lessons learned from Seeker's first and last flight, which I'll definitely take into account when building my next rocket. If you have any suggestions for improvement, let me know in the comments below. Thanks so much to the Bri'ish Engineer for collaborating with me on this project. Please check his channel out. Other than that, remember to like and subscribe, and I'll see you in the next one.